everyone, my name is Camille Sosa. So for today's video, I'm just going to discuss about the summary of chapter 4. The topic of chapter 4 is network access. So if you're interested in this topic, please keep on watching. Network access. To support a communication that the iOS model divides the functions of data network into layers. Each layer works with different layers above and below the transmit data. Whether connecting a local printer to the home or website another country before any network communication can occur, a physical connection to a local network a physical connection can be a wired connection using a cable or a wireless connection using radio waves. Network interface cards or NICs connections a device to the network. Ethernet are the used wire connections shown, whereas a WLAN or WLAN or wireless local area network are used for wireless, and an end-user device may include one or both printer for as example for only any internet or wireless devices must share access to the airwaves connecting to the wireless access point. This means lower network performance may occur as more wireless devices access the network simultaneously. A wired device does not need to share its access to the network with other devices. Each wired device has a separate communications channels over its Ethernet cable. This is important when considering some application as online gaming, streaming video, and video conferencing, which requires more dedicated bandwidth than other applications. The process that data undergoes from a source node to a destination node is the user data is segmented by the transport layer, placed into packets by the network layer, and further encapsulated into frames by the data link layer, which is discussed in chapter 3. The physical layer encodes the frames and creates the electrical, optical, or radio wave signals represents the bits in each frame. These signals are then sent on the media one at a time. The destination node physical layer retrieves these individual signals from the media, restores them to their bit representations, and passes to the bits up and data link layer as a complete frame. There are three basic forms of network media: copper cable, fiber optic cable, and wireless. The copper cable, the signals are pattern of electrical pulses, while the fiber optic cable, the signals are patterns of lights, and wireless, the signals are patterns with microwave and transmission. So for the three electric pulses, lights, and microwave transmissions. So, physical layer standard, the protocols and operations of the upper OSI layers are performed in software designed by software engineers and computer scientists. The services and protocols in TCP/IP are defined by the Internet Engineering Task Force or IETF. The physical layer consists of electronic circuitry, media, and connectors developed by the engineers. Therefore, it is appropriate that the standards governing this hardware are defined by the relevant electrical and communication engineering organizations. So, functions start with encoding. Encoding or a line encoding is a method converting stream of data bits into the predefined code. Codes are groupings bits used to provide predictable pattern that can be recognized by both senders and receivers. In the case of networking, encoding is a pattern of voltage or current used to represent bits, the OS and 1S, which is the only number that can be readable by the computer. There are many ways to transmit signals. Common methods to sense data is using modulation techniques. Modulations is the process by which the characteristics of one wave or the signals modifies another wave or the carrier. The nature and actual signals representing the bits on the media will depend on the signaling method in use. Bandwidth is the capacity of a medium to carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. Bandwidth is typically measured in kilobits per second. Megabits per seconds or gigabits per seconds. Bandwidth sometimes thought as the speed that bits travel. However, it's not accurate. The examples in both 100 MB. Let's proceed to the throughput. It is measured the transfer of bits across the media over a given period of time. Due to a number of factors throughout, usually does not match the specified bandwidth in physical layer implementations. Many factors influence throughput, including the amount of traffic, the type of traffic, and latency created by the number of network devices encountered between source and destination. The physical layer produces the representations and groupings of bits as voltages, radio frequency, and light pulses. Various standards organizations have contributed to the definition of physical, electrical, mechanical properties in media available different data communication. These specifications guarantee that cables and connectors will function as anticipated with different data link layer implementations. Physical components, hardware device, media, and connectors which transmit and carry bit signals. Signaling methods, how 1S and 0S are represented on the media varies depending on the encoding scheme. Synchronous, evenly spaced time durations for signals, and prime encoding method converting streams data bits into groupings of bits predefined, and asynchronous, arbitrarily spaced time durations for signals. The time and voltage values of electrical pulses are also susceptible to interface from two sources. Electromagnetic interference or radio frequency interference signals can distort and corrupt data signals being carried by the copper media. Crosstalk is a disturbance caused by the electrical or magnetic fields of signals on one wire to signal adjacent wire. In telephone circuits, crosstalk can result hearing part of another voice conversation from adjacent circuit. So, the twisted pair cable. The outer packet protects the cover wire from physical damage. Twisted pair protects the signal from interference, and the color-coded plastic encapsulations electrically isolate wires from each other and identify each pairs. Shielded twisted pair provides better noise protections than UTP cabling. However, compared to UTP cables, STP cable is significantly more expensive and difficult to install, like UTP connector. Although UTP cable has essentially replaced coaxial cable in modern Ethernet installation, the coaxial cable design is used. Wireless installation, coaxial cables attach antennas to wireless devices. Cable internet installation, cable services providers provide internet connectivity to their customers by replacing portions of coaxial cable and supporting applications elements with fiber optic cable. So, the new internet or 10 GB standard uses this form of copper media, which is STP. Coaxial attaches antennas to wireless device can be bundled by fiber optic cabling of two-way data transmission. STP counters MEI and RFI by using shielding techniques and special connectors. The UTP most common network media, and the coaxial terminates BNC and N for F then type connectors. Cancellations. Designers now pair wires in circuits, then two wires in the electrical circuit are placed close together. Their magnetic fields are the exact opposite of each other. Varying the number of twists per pair wire pair. To further enhance the cancellation effect or pair circuit wires, designers vary the numbers of twists of each wire pair in the cable. UTP cable must follow precise specification how many twists or braids are permitted per meter of cable. So, bad connector wires are exposed and twisted and not entirely covered by the sheet. Then, good connector wires are untwisted and extend necessary to attach the connector. Ethernet straight through, the most common type of networking cable. It is commonly used to interconnect a host to a switch and switch to a router. Ethernet crossover, a cable used to interconnect similar devices, for example, connect switch to switch, host to host, and router to router. However, and then the rollover is a Cisco proprietary cable used to connect workstation to a router or switch console port. After installation, like the one shown, should be used to test following parameters: wire map, cable length, signal loss due to annotation, and crosstalk. Enterprise network used to backbone cabling application and interconnecting infrastructure devices. Fiber to the home (FTTH) used to provide always-on broadband service to homes and small businesses. Long-haul networks used to service providers to connect countries and cities. Submarine networks used to provide reliable, high-speed, high-quality capacity solutions capable of surviving harsh undersea environment to the transoceanic distance. Small core, less dispersion. The single mode is small core, low dispersion, suited for long distance applications. Uses lasers and light sources. While the multi-mode, larger core than signal mode cable allows greater dispersion, therefore loss of signal, suitable for long distance applications. Uses LED light source, commonly used with LANs and distance of couple hundred meters within a campus network. The SD connector, one of the first connector types used to connect the connector locks securely with a twist-on-twist bayonet style mechanism. While the SC connectors, subscriber connectors, sometimes referred to as square connectors to standard connector. It is widely adopted LAN and WAN connectors that uses push-pull mechanisms, positives insertions. The listen connectors, smaller version of fiber optic SC connector. The duplex multi-mode LC connector, similar to LC simplex connector but using duplex connector. Misalignment. The fiber optic media are not precisely aligned to one another when joined. End gap. The media does not completely touch the splice of connections. And finish. The media ends are not well polished or that present on the termination. So, wireless does have some areas of concern, including coverage of area, interference, security, shared medium. So, the data link layer is divided into two sub-layers, logical link control LLC and media access control MAC. This lower sub-layer defines the media access processes performed by the hardware. Point-to-point, this is a simplest topology that consists of a permanent link between two endpoints. For this reason, this is very popular. One topology hub and spoke, a one version of a star topology in which a central site interconnects branch sites using point-to-point links. Mesh, this topology provides high availability but requires that every end system be interconnected to every other system. Therefore, its administrative and physical cost can be significant. Each link is essential. A point-to-point link the other node variations of this topology. So, star and devices and connected to central intermediate devices. Extended star is an internet extended star topology. Vast infrastructure devices such as switches are not required to interconnect to the devices. Have duplex communications. Both devices can transmit receive on the media but cannot do simultaneously. Full duplex communication. Both devices can transmit and receive the media at the same time. The data link layers assumes that the media is available for transmissions for both nodes at any time. Contention-based access. All nodes operating in half-duplex complete for the use of medium, but only one device can send it at a time. The controlled access. Each node has its own time to use the medium. These deterministic types of network are efficient because a device must wait its turn to access the medium. The frame. Frame is a key element of each data link layer protocols. Although there are many different data link layer protocols that describe data link layer. Addressing indicates source and destination nodes. Type, control, data, error detection. So that's all for today. So I hope you enjoyed my video. So if you are interested for more further topic about in Cisco is CNA and A1. So please keep on watching on my video and stay tuned.
Bless the